A spinner is designed so the probability it lands on green is 0.4. Ashu has 16 spins. Find the probability that Ashu obtains A, no more than 3 greens, B, at least 7 greens. For a game, Ashu wants the probability of winning a prize to be less than 0.1. Each player is given 16 spins and the number of greens is recorded. What is the least number of greens that are needed to win the prize? Okay, let's deal with these two things first. So let x be the random variable, the number of greens obtained in 16 spins. So we've got a fixed number of trials, 16, and a probability of success of 0.4, failure 0.6. So x will be binomially distributed, n being 16, and p, the probability of success, being 0.4. B, we want the probability of no more than 3 greens, which means the probability that x must be less than or equal to 3. So if we go to the GeoGebra applet, you can get the pot of the probability calculator now. Okay, so we want less than, so that's that one, and in here we want that to be 3, and that's so what we need to do is sum those probabilities up. But if we go to the community distribution function, the table will give us it at 0.0651. So using the PDF, we get that, and we need to sum those probabilities, which we could do, but from the CDF table, which sums them up for us, this is 3, which is the sum of all those 4 there. That gives me 0.0651. So the probability that x is less than 3 is 0.0651. So no more than 3 means x is less than or equal to 3. Part B, x is still binomially distributed 16, 0.4. We want the probability at least 7 greens. At least 7 greens means 7, 8, 9, 10, 11, 12, 13, 14, 15 or 16. So we want the probability of x being less than or equal to, greater than or equal to 7. So using the PDF, so greater is that one, and then put in there 7. So we need to sum up all these probabilities here, okay? Or in order to do that using the CDF, we need to take that the whole lot adds up to 1, and then take away the probability of being less than 6. So we'll need to know that one there. So from the CDF table, that's 0.5272. So you add those up to get the answer, or from the CDF table, we need to take the one below 7, which is 0.5272. So the probability that x is greater or equal to 7 will be 1 minus the probability that x is less than or equal to 6. So we need to take that one there, 1 minus 0.5272, which is equal to 0.4728, and to 3 significant figures, 0.473 to 3 significant figures. Now, this is at least 7 greens, so at least you need to do 1 minus less than the probability of one less than the number that you're considering. So 1, all of it, taking away the unshaded area, which is probability of x being less than or equal to 6, which is 1 less than that. We need to bear that in mind in doing the next part of the question. Right, for a game, Ashu wants the probability of winning a prize to be less than 0.1. Each player is given 16 spins and the number of greens is recorded. What's the least number of greens that are needed to win the prize? Right, so same distribution. Let G be the smallest number of greens to win the game. So we want the probability that we get at least G is less than 0.1. So to repeat that, probability of at least G greens must be less than 0.1. So going to the CDF table, we can calculate, use this, where is this going to be one less than one of these? So we need to do one, take away one of those. It might be easier to look at it going to this. Let's just put in okay, so that was what we wanted. Say the answer was 10. Then we would need to do, to find that, we would need to do 1 minus all of these. So 1 minus the 1 just before 10 will give us the answer. So using the CDF, in the CDF table, so this is the CDF table for, if we do probability x is greater than or equal to 9, we need to do 1 minus the probability before it. Don't forget this is the sum of the first 8 here, which gives me 0.1423. That's not okay because that's more than 0.1. So if we look at the next one, x is less than or equal to 10, we need to do 1 minus the one before, which gives me 0.0583. Now that is less than 0.1, so that is the first time that happens. This is the first time it happens. Therefore, at least 10 greens are needed to win the prize. This is how this method works. If you look at this, we require probability x is greater than or equal to g less than 0.1. Okay, from here, probability x greater or equal to 9 is 0.1423. That's not what we want. We want it less than that. So this is the first time it happens. Probability x is greater or equal to 10 is b equal to 0.0583. This is the first time where it's at least. So at least 10 greens are needed in order to win the prize with a probability less than 0.1. This is how it works. I hope you've understood, and I thank you very much for watching.